Good afternoon, everybody. Welcome to the second of our Hartwig Lathe programming webinar series. Today, we are going to talk about multifunction machining. We will be discussing C-axis machining, how to use live tooling in a Okuma lathe with an OSP control, and how to program the Y-axis, as well as some of the options associated with a Y-axis machine. As we said in our last video, Hartwig helps people in manufacturing control their destiny every day. So with the challenging times that we're facing and not being able to get together in person, this is one way that we would like to be able to reach out to you guys and still share information and try to continue the training and relationship virtually. Some codes to be aware of associated with multifunction machining. G136 is going to turn off Y-axis mode or coordinate conversion. As a part of that, if Y-axis is not at 0, to be off the part and in a safe position for Y to go back to 0. G137 turns on coordinate conversion mode. Coordinate conversion mode is a way to program the C-axis to machine a shape or a contour, but using Y-axis commands and letting the machine convert into C-axis motion. And then G138 turns on your Y-axis mode. M12, M13, and M14 are going to control your spindle direction and on-off. M110 is going to clamp the C-axis joint as a fed axis instead of your spindle. And then M147 engages the brake to hold the C-axis in position for heavier milling operations. It's important to note that the X value will become radius when Y-axis control mode or coordinate conversion control mode is turned on. Once you command G137 or 138, the machine is programmed in radius until G136 is commanded. A function I use a lot on the P300 control is something called machining mode designation function. So what this allows you to do is, instead of having to command M110 to engage the C-axis, then G138 to turn on Y-axis, let's say, G272 is Y-axis machining mode. It will automatically activate both commands. In the same, let's say Y-axis mode was turned on, and I wanted to go to C-axis mode only, G271 will turn off Y-axis mode and engage the C-axis. G270 will automatically cancel both functions to get into what they call turning mode. Now, like I said, this is a P300 only function, but it's a nice little shorthand to save you a line or two of code. If you have a 2-spindle machine, these G-code commands are followed by an SP equals for main spindle. That would be SP equals 1. And for sub-spindle, that would be SP equals 2 to tell the machine which spindle to command these on. There are also fixed cycles we can use, similar to that of a machining center. G180 will cancel any fixed cycle. If you do not command G180 after a series of fixed cycle positions, each position thereafter will execute that cycle again. So it's important to use G180 to cancel when you are done with whatever cycle. G181 versus G183 is just drilling with a PEC or no PEC. G184 is not function I use typically. This is a parameter controlled tapping cycle. So it is going to be float tapping when the machine is set to float. And all of the machines come from the factory set to float as a standard. Whereas if you use 178 or 179, that will always be synchronized or rigid tapping, meaning you just mount your tap in a collet and it will tap fine. With 184, the parameter has to be set correctly, and if it's set to float, you must use a special floating collet. For all of the above cycles, you can also use a Q value if you have a bunch of holes equally spaced around the outside diameter of a part. For instance, if I have Q6, the machine will drill 6 holes around 360 degrees, meaning it will drill 6 holes 60 degrees apart around the outside of my part. This is the G184 tapping parameter I was referring to. You'll go to optional parameters, multiple machining, and typically it's around number 6, depending on how new or old your machine is. There may be a couple more or less parameters on this page. And you have to set G184, G298 mode to float or concurrent. Concurrent is the wording for rigid tapping. Another parameter that is useful is the M-axis spindle rotation parameter. Depending on the brand of live holders you're using, M13 may not be clockwise on your holder, even though it's clockwise to the machine, which means you need to reverse the direction of M13 and M14 in the machine so that they drive your holder in the proper clockwise or counterclockwise direction. Now, the reason for that is because if you go to use any of the fixed cycles that I just talked about, the fixed cycles make sure your tool is running in a clockwise direction for a drill or a counterclockwise direction for a left-hand tap. The cycle will overwrite your spindle direction commanded in the program based on this parameter setting and what direction that cycle needs to run for a right or left-hand operation. The way you would toggle the rotation reverse is simply to highlight the station number that you would like to reverse the direction on, press F1, and then press F3 to check mark. Do we have any questions, Joe?
I don't see any yet.
Okay. This is a sample program for a simple multifunction part. So we have some simple turning first, similar to what we talked about in the last webinar. We have our G50 for max RPM. We have a rough turning cycle, followed by a finish turn. But at the end of my finish turn, I am going to stop the spindle and we have G271 SP equals 1 to drill the hole. What that means is C-axis machining mode, which will stop the spindle, engage the C-axis, and orient to 0, preparing to be commanded to an orientation. We're calling up tool 3, T0303. The reason this is only a 4-digit instead of a 6-digit is because we're not using tool radius compensation for our drill. To command spindle speed for a live tool in an Okuma lathe, instead of S and a number, we use SB equals. In this case, SB equals 3,400 RPM. M13 for clockwise rotation. We're rapiding to a starting point That will be my hole location in X and 100 thousandths off the end of the part. And this is in diameter because we're in C-axis mode. G181, we're going to use a drilling cycle with no peck. At our X position, we pre-position to. Drilling to a depth of -1 inch 150. C0 says do this at orientation 0. I could command multiple C orientations after this line to drill more holes at in a pattern. R of 100 thousandths is going to be my feed plane and where I wrap it back to. K is 0 in this case, but what K is an incremental shift. Say I had a counterbore that was already machined and I just wanted to drill from the bottom of that deeper. I could shift the depth of my counterbore and drill from 100 thousandths away from that surface rather than cutting air. And that's done with a positive number, and the machine will automatically shift in the proper direction based on your endpoint. And then a feed rate of 5 thousandths per rev chip load. This is my only hole, so I have G180 to cancel any future cycles. Rapid to the limits, M12 will stop the live tool spindle. You have to stop the live tool spindle before disengaging the C-axis or the machine will alarm out. And then finally, we have our G270 SP equals 1. Let's see how this runs. Okay. Do we have any questions about the first sample program, Joe?
I don't see any, Ricky.
This second program is a little more complex. So I eliminated the turning portion to save space. That's something similar and we've seen before. We talked about in our last webinar, the turning and grooving portion. Now I'm getting ready to mill a flat using Y-axis and drill 2 holes offset in the Y-axis direction. So first, I have this local variable CRC equals. What I'm using this for is to compensate for the radius of my tool. This is a really easy shortcut way to not have to use a calculator to do the math for yourself. You can just put print dimensions plus or minus the radius of my tool to compensate in the right direction. So we're at the limit, T0404 to call up my milling tool, M110 to activate C-axis. So this time I'm not using machining mode designation function. This program would apply to any Okuma control. M110, SB equals 6,000 RPM, M13 for clockwise rotation, rapid to a clearance position of 100 thousandths away from my 4-inch diameter, and the radius of my tool will be 100 thousandths off the end of the part, using my CRC local variable of the radius of my cutter to compensate that. G138 turns on Y-axis machining mode and turns the machine into radius. So from this point forward, all of my X positions will be in radius. Then I'm rapiding the Y-axis down below the part, -2 minus the radius of my tool, bringing Z over to get ready to take my first pass, going into G1 mode to feed, and using G94 to go into feed per minute mode for the milling application. We're going to take 100 thousandths per pass radially at a feed of 45 inches per minute in feed. Then y-axis is feeding up to the top of my part at 90 inches per minute cutting feed. We're taking 4 steps across, rapid back to my start point of 100 thousandths away in X, back to the front of the part, back down to my start point in Y, and taking a second pass. All the way down to X of 1.6 in radius or 3.2 in diameter. Then we have G136 at a safe clearance plane to turn off y-axis mode. Y will go back to 0 and turn off. M109 will disengage the C-axis, and M12 will turn off my live tool. Now we're going to drill our 2 holes. So we have T0505, M110 to engage the C-axis again. Turn on the live tool to 3,500 RPM clockwise. And we go to our first hole location, 100 thousandths away from the OD of the part. Turn on y-axis control mode and go to our first Y position, which is minus 700 thousandths. G181 activates my drill cycle. And below my G181, I have my second hole location. So my first hole was at Z of -1, Y of -0.7. My second hole is at Y of 0.7, Z of -4. G180 cancels my drill cycle now that I've executed my 2 holes. G136 will turn off y-axis control mode. M109 will disengage the C-axis, and M12 will turn off the live tool before ending the program. So we see our live tool come in here after this grooving tool. See our live tool come in, step down, mill across. We'll have a nice flat when that gets done. We'll see the drill come in next. Drill my 2 holes. Any questions on that, Joe?
It must be shy today, Ricky.
It's going to be a quick one then. Y-axis offset turning is a function that is available on the OSP controls. Historically, this has always been an option on lathes with y-axis, but has become a standard recently. What this allows you to do is stack multiple turning tools or multiple tools, such as the image here, and use the y-axis to put the tip of the insert in the proper cutting position with a y-I offset. Now, when doing this, it's very important to note to get the y-axis out of what they call y-axis turning position in the program. You must cancel the tool offset for Y with a T0100 or whatever station you are using. Then command the machine to Y0 and go to the X limit before indexing to your next tool. Now, something to be careful of when doing this, the machine, when you cancel the tool length offset, may move in the Z or X axis as well by the offset amount of your tool. So it's important to be at a very safe distance away from the part when doing this. However, if you go too far, you may run into clearance issues with the sheet metal with a long tool sticking out of the bottom of the turret. So you have to be very deliberate in how you turn off the Y-axis turning function when you are programming it for your applications. If anybody has any questions after the webinar, you're always welcome to reach out to your local office, or we now have an AE support system that went live this week. The phone number is 314-684-4200, or you can email aesupportstl@hartwiginc.com. This will put you in contact with one of us engineers in the St. Louis office. It will ring all of our phones, and whoever's available will pick up and help you out. The email will send all of us an email letting us know your issue and what help you need for one of us to respond, whoever is best suited to help you. If you do not get anyone and you leave a voicemail, we will all get that voicemail emailed to us, and whoever is best suited or available at the time will reply as soon as possible. This can be a great way and a great tool for you to get some immediate assistance if you're in a bind on your machine. The other regions will be rolling these out as well. So if you're in our Kansas City region, I know this is already live for them, and some others will be coming later. Any final questions, Joe?
Question queue still empty.
All right. Thank you guys for joining us today. It was a lot quicker than expected, but I hope you guys got some good information out of it. And we look forward to joining you next month when we will be talking about basic machining center programming. Thank you and enjoy the rest of your day.